This is the Office Hours video for Section 8, Significant Figures. And significant figures are important in that they relay what the accuracy of the number is. Now, one issue you might run into with significant figures is that there is some ambiguity in how many significant figures there are. When you deal with numbers that are greater than 1 and that end in a bunch of zeros. So, for example, let's say we looked at a force magnitude, some big force, and we got a number 123,000 newtons. So newtons are the metric units of force. Notice I'm writing this as a symbol, an equal sign, a number, and some units. And so one question might be, what is the accuracy of this measurement? How many significant figures does it have? So when you look at it, you can't really tell, because those zeros could be indicating part of the measurement, or they could just be placeholders. So a good way to specify the number of significant figures is to write the number in exponential form. Let me show you a few examples. So here's one possibility. The force magnitude might be 1.230 and 3 more zeros times 10 to the 5th newtons. So if you start with the decimal point, which is implied to the right of the rightmost zero, and move it over 1, 2, 3, 4, 5 places, then you end up in between the numerals 1 and 2. So in this case, if you start from the left, starting with the leftmost digit that's not 0, that's the 1, and count the number of digits, this has 6 significant figures. And so if you wrote down the number like this, what you're saying is, we measured all the way down to plus or minus 1 newton. So this wasn't 122,999 newtons, and it wasn't 123,001 newton. It was 123,000 newtons. Measured all the way down to plus or minus 1 newton. On the other hand, the measurement might not have been that accurate. So here in this example, number 2, I'm going to write the same number with fewer significant figures. We could also call this scientific notation, because we normally use 3 significant figures in scientific notation. And so in this case, you can see there's only 3 significant figures, and this indicates much less accuracy in this measurement. So what's happening here is the measurement was made to plus or minus 1,000 newtons. So it wasn't 122,000 newtons, and it wasn't 124,000 newtons. It was 123,000 newtons. Now, we could even go beyond the 6 significant figures that I had before. The number of significant figures can be anything. And if this force magnitude was measured really, really well, you can go even further than where the original decimal point was. I'm going to add on a couple more zeros, still times 10 to the 5th newtons. And so now, if you count the number of digits starting from the left, starting from the first digit that's not 0 on the left, then there's 1, 2, 3, and then 5 zeros. So that's 8 significant digits. So all of these measured values are the same. They're all equal to 123,000 newtons. The difference is how accurate were the measurements when they were made. So that's one thing to watch out for, is when you have big numbers and there are zeros on the right which are just placeholders. If you write it just as a regular old number, then it's not clear how many significant figures there are. So when I originally wrote this, it wasn't indicated what the accuracy was. So if you have numbers like that, it's a good idea to convert them to exponential form. Some number times 10 to some power. And then you can explicitly write the number of significant figures. So that'll be a better way of doing things. So this is an exception you have to watch out for, where there are a bunch of zeros acting as placeholders. So think about that a bit, and when you go to answer questions, be sure to include the right number of significant figures, which represents the accuracy of the answer. Okay? So that's it for now.